Hello! Welcome to this video tutorial. For this lesson, we will be expounding more the different states of matter. You have discussed this in length starting from grade school to high school. However, before we proceed with our lesson, let us first review the different states of matter. Let us start with solids. Then we have liquids. And finally, gases. In a nutshell, we can see that the three states of matter have very obvious differences in terms of its molecular structure. Based on this arrangement, which state of matter do you think has the highest amount of energy? I will give you a moment to think about the answer. You may pause the video for a while. If you are thinking that gases have the highest amount of energy, your answer is correct. For this lesson, we will be delving further on the different properties of gases. By the end of the lesson, we will also be touching on some other related topics like the kinetic molecular theory. At the end of this lesson, you must be able to investigate the different properties of gases as stated in the kinetic molecular theory, and use the gas laws to determine pressure, volume, or temperature of a gas under certain conditions of change. Gases have four basic properties. First, it has no definite shape and volume. That means, gases adapt to the shape and volume of its container. This property is similar to that of liquids also. Second, gases diffuse easily. Since gases have wide spaces in between each molecules, it can easily mix with other types of gases. Third, gases have low densities. Why is that so? It is simply because gases are mostly made up of spaces. The molecules of a gas are so far apart from one another that in between each of these particles are vast amount of spaces. And lastly, gases can be compressed easily. Again, this is due to the large amount of space in between gas molecules. As a matter of fact, you can store a large amount of gas in a small container. Based on the assumptions between these four properties, we can see that gases have very much different properties compared with solids and liquids. However, we must ask ourselves a question: are gas particles stationary or in motion at space? I will give you a moment to think about the answer. You may pause the video for a while. If you are thinking that gas particles are in motion, your answer is correct. As a matter of fact, this notion that gas molecules are in constant motion gave rise to a theory known as the kinetic molecular theory. The kinetic molecular theory has four basic tenets. 1. The gas molecules are far from one another. This is because, number 2, there is a very weak or no intermolecular force that exists between these gas particles. 3. Gas molecules are in constant motion. Not just any motion but linear motion. So why are gas molecules changing direction? Again, you may pause the video and think about the answer before continuing. If you think that they are changing directions because they are colliding with one another, that's correct. And fourth, since gas molecules are moving, they also have kinetic energy. The kinetic energy of a gaseous system is very dependent on its temperature. Based on these four tenets, when gas molecules are heated, what do you think happens to the motion of the gas particles? And what is its effect on the total kinetic energy of the gaseous system? I will give you a moment to think about the answer. You may pause the video for a while. The answer to that question is this: when gases are heated, the molecules will move faster. Since the kinetic energy is dependent on the movement of gas molecules, when the molecules move faster, the kinetic energy increases. So heating a gas increases its kinetic energy.